Hello.
Hey, hello.
Nice.
Good. This is still morning, afternoon, midday, wherever you're located.
For me, it's still morning,
Mhm.
but I think for John, it's almost evening.
I think
And
for us it's like afternoon.
yeah,
Yep.
Yeah, it's evening and I'm still eating my dinner.
Let's give folks a minute or two to join. Well, I'm just getting myself situated here. You'll be able to see my screen. Beautiful. Well, hopefully beautiful anyway. Good morning, Jason. Was it afternoon for you?
It is officially afternoon. I'm in Austin, so
Okay. Give folks one more minute and then I'll get started here. Let's go at least start the agenda. Um, so start with taking opens, and then I'm kind of hoping that we can kind of finish up that life cycle of a problem discussions we've been having. Um, Austin, sorry I wasn't able to reach out to you earlier. Were you able to put something together for the crash handling?
Yes. No.
Oh, excellent. So I'll do that first, and then um, I want to kind of look at the debug activities that we have kind of extracted from the from the various flows so far, and probably add to that. And then that's probably realistically what we're going to get to. So, all right. Anybody have any opens, announcements, pass downs, whatnot? All right, none for me. Um, Austin, do you want to share? I probably have to stop sharing before that's possible, right?
All right. Yeah, let me share here. Okay. So yeah, I mean, like we discussed, I think there's a lot of kind of common themes with the other ones. But I put here into the considerations like self heal. If you do crash, self heal is preferred, and so that was one of the call outs, and it may dictate the path you take depending on whether self heal was possible or not. And I also put that another consideration is that if you crash, you might not be able to access the debug or diagnostic data. So this would be a little bit different than like the performance issue handling or the preemptive issue handling. Because in this case, the system or component may be so crashed, or maybe crashed so hard it can't even process or can't even run the code to generate the debug information or process the commands to retrieve for the host to retrieve it or whatever. So that one was a little bit different there.
Yeah, you most certainly not can bank on being able to like log into the machine, quote unquote, and peek and poke around, right?
Yeah. Yep. Exactly.
Mhm.
Yep.
But I think that's an important point because we haven't really defined what crash is, and I guess there are different degrees of crash, including, some where maybe you have some capability and others where you may have nothing. Um,
Yeah.
Yeah.
Yep. So yeah, I kind of, kind of wrote this towards, the bookends of like, yeah, you fully self-heal and keep going, or you're totally crashed, you can't get everything. Of course, there's everything in between. Yeah. So for the boundaries, these are kind of the same boundaries as a lot of the other ones. I mean, obviously, you don't want to impact performance, but I will on all of these. I put like in data center, and this was really going back to this slide down here, right? Because we kind of if you're these we're supposed to handle all these different use cases, and if you're in this silicon provider or OEM pre-production environment, you probably the performance impact or customer data sensitivity, these sort of things kind of don't matter. It's really once you get into the data center that those things would probably be more more of an issue. So that's why I kind of phrased it as this would be a boundary condition in the data center. Pre-production is probably not a boundary that needs to be worried about as much. Same
And,
thing. Go ahead.
So that's actually I want to phrase it as a question, but so in my head, right, right, if you have a crash, right, the cure to crash is probably a reboot, right? I'm gonna ask that as a question. Is that a true statement, or do we see clearly you crashed, so the performance has been impacted, as you probably we call probably the workload got went to a screeching halt, presumably, right? So the question is the cure always a reboot, or do we see is there something else that we envision here?
Yeah, that's what's going on. The self-healing is probably preferred, and I did put some specific examples below. So the like so a few examples here that I could think of. Is that let's say you had a fatal PCI Express error. This is typically escalated to the host operating system as a fatal error. So like an x86, this would be like an NMI. And the host response to NMI would be to crash, right? So this would be like a blue screen in Windows or a kernel panic in Linux, and the whole system just goes down. And right, but they have a technology called downstream port containment error recovery. And so Linux, for example, if you support this, you can actually recover from that crash at runtime and keep going. So basically the PCI device would get reset, the OS would reload the driver and keep going. And you may be able to do that. Obviously there will not be zero performance impact, but that impact should be minimized. If it only happens, if it's a very transient failure, it only happens once in a very, very rare occasion, maybe that's acceptable. The other option that I've seen employed today is is the device could do a self reset if the device itself crashes. So for instance, the OCP NVMe specification requires that if a device crashes and it has a firmware assert, it says, hey, you should try to automatically reset yourself, reboot your firmware, and there's a method defined to do that kind of seamlessly with the host. So basically the host device driver and endpoint are kind of in conjunction and can survive that sort of operation, right? So that's kind of where my head was at. Does that make sense, Marco?
Yeah, it makes sense. And I mean, I think what's clear is the and again, let's have a discussion about it, right? The thing that crashed, right, or big or small, needs to be reset, right? Whatever it might be, but there's clearly a need to reset fast, get back to work fast, and one of the techniques is to minimize the blast radius of what needs to reset, right? Like as you are describing here, right? If the NVMe drive can self-reset without the having to take the entire node with it, that's what we want.
So one I guess one question I have here, like, so when I'm doing self-healing and I want to do like downstream port containment, I imagine like maybe some of these techniques are gonna involve or require some they're going to involve some sort of time constraint. It has to be done within this amount of time. So maybe that's true, maybe that's not true for all of them. But one of the actions generate crash dump is might there be some self-healing options where we don't have an opportunity or maybe a crash dump? Is it something we want to do? And I'm just trying to understand the relationship behind all of these actions and something like self-heal versus something that can't be self-healed.
Yeah, good question. My thinking here was, and this is I've seen it play. I guess if you self-heal, maybe you don't always generate a crash dump, but the way I've seen it before is, and again, just going back to NVMe, since I worked on that a lot, is that even if the device self-heals, something went wrong, and it was at least a little bit disruptive. And so it would be good to get some information about that, right? So we would say, oh, you had a crash, you recovered, that's great, but let me go ahead and get that crash dump information in case this is an issue that occurs frequently. I can get that debug data and try to fix it. Now, if it's a once in a blue moon thing, and you might say, oh, well, I've been doing this forever and I just saw this one crash, the host may say, I'm not even going to bother, trying to get that crash dump. But if it's something that happens frequently, you may want to do that even if it was recovered. Was my thinking.
Yeah, and I mean my thinking is here, right? Like, you probably want to generate the crash dump on any crash, right? And then leave it up to the person running the data center to evaluate. This is okay, I've never seen an NVMe drive crash before. Interesting. I got bigger fish to fry, and I'm not going to worry about it. And look, it never crashed again for another 5 years, so probably never ever going to look at it. Versus, okay, these things. This is now the third drive that crashed today. I probably should go look at that. Or the specific drive has crashed for the fifth time today. I definitely should look at that.
Yeah, and I had this kind of in mind too, going back to the CPU, kind of is like, well, it maybe just generating that crash dump, it could be huge, right? And so maybe if you self-recover, you don't want to get all the data. And so you could have something like this model where a lot of this stuff, like the extended register dumps, maybe by default, you just collect some amount of data, but not all this extra stuff down here. And only if the host saw something happen multiple times, and it might go in and say, hey, I actually need more debug data. Let me go enable you. Next time you have a crash, do the extended register dump and the trace dump and all that kind of stuff.
Yeah. Or maybe next time you or in the extreme case, next time you crash, you please do not self heal, right? Stay in that place.
Yeah,
Yeah.
I don't want to go into a rat hole on this, but I did look at that document, and it talks about, I guess the availability, or the ability, the availability to do a crash dump is sort of paramount, right? So that there shouldn't be a case where it's you don't have the ability to access or perform that crash dump. So I just want to I think we talked about that in the first bullet, that there may be cases where we can't do that.
Mhm.
But that's sort of in conflict with the hyperscaler spec. And from a practical perspective, I think you got it right. But I just wonder, like, because those specs are also talking and defining debug dumps and crash dumps and things of that nature. Our role here, is it to sort of reinforce that spec, or
Yeah, so that's actually a good good point of conversation, right? Austin, maybe can you go to slide? I think it's slide 5. That's where I made this. Yes, slide 5.
Well, 5.
Yeah, sorry. Yeah, so the way I look at this, right? But this is the flow from the hyperscaler CPU as workstream. I think that's what it's called. And what we want to do, right, is I'm perfectly happy with them owning this flow. And what we want to do here is we want to define how to perform these activities that have a circle around them, right? Like, how do I get a crash dump in a standardized way where any yeah. How do I get a standardized way? For example, a crash dump in a standardized way where the same tool can extract the crash dump out of an NVMe drive, NVIDIA GPU, or an Intel CPU, and any other components, right? That's what we are.
not the contents of what a crash dump is, like what state is read.
Yeah, not
but
the
rather
content.
the transport mechanism.
Exactly. Like, how do I get this? Exactly. How do I get the dump over
Okay.
here, right? In a standardized way. That's what my view is, where we should focus on, A, to keep our scope in check, and B, to not have conflict with these other work groups, right? Because neither of those things are really productive at the end of the day. Right, Austin, sorry for the interruption. Austin, it feels like you're speaking on mute.
Oh, yeah,
Yeah.
it was. Thank you.
Thank you.
Yes, thank you. So I'll going back up to the boundaries. So the second boundary condition is that I put that it may be limited to human readable in the data center. Again, in the data centers where you have to worry about like the customer data. And I also put may, because we do have some of our customers are okay to send encrypted debug data outside their data center. So others, strictly won't allow that, right? But so that's why I put may here.
And that probably also interacts with that enabling more data kind of thing, right? I mean, I can see that the even the same customer, like when they have this crash dump that gets collected every time something happens, they may want that readable, human readable. But if you're going into this, okay, well, really gotta go and dig a little bit deeper than that maybe, well, not being human readable by the data center provider might become more palatable, when it's clear that that initial data wasn't.
What is human readable? I'm sorry. What does human readable mean in this case?
So yeah, it means that in order for the data to leave the data center, then they would have to have security folks review the information that's leaving the data center to ensure that it doesn't have customer data. So it just needs to be in some format that they can look at it and ensure it doesn't have customer data.
Yeah,
And
I
so it
mean,
has
at
to
least I
be-
was told it's ASCII. Usually it's just ASCII text, right?
Yeah, it could be UTF-8 or what. I mean, like
Okay, yeah, but it
yeah.
needs to be, yeah, like regular readable text, not binary or something like that.
and not encrypted.
it-
I think is the other.
Yeah.
I mean,
no,
encrypted is the other extreme, right? But it could also just be a, a compact binary, like a compact binary format that takes an Intel tool to unpack is probably already, if somebody's paranoid enough, not acceptable.
But is that something we should
Well,
define?
well, I don't know about that, but let me give you an example. Yes, I agree with Marco's statement about the so in the OCP NVMe data center spec, the way it's done is they have the crash dump is split into 4 different areas. So data, the first data area is a small amount of data, and it's to collect it. It does not impact the performance of the device. And in addition to being available on a crash, the host can also go read that same information on demand periodically without impacting performance. And that is actually a binary format, but in the case of NVMe, they define that format, and then they have an open source tool that can parse it into a human readable format. So the data that comes out of the device doesn't necessarily have to be ASCII, but it needs to be in a be convertible to human readable. Maybe I'll say that.
I guess it needs to be like if it's a compact, it needs to be convertible into human readable, following an open source tool or a tool I could be writing myself. Right? It has to be a known format if it's a compacted format, right? It probably can't be converted to a human readable format by a tool that only Intel understands. Or in our case, or somebody else's, right? Knowing my security friends, that's where they probably
I'm
draw
sure
the
this
line.
would be the preference, but yeah, I don't know if it's a hard requirement that it has to be open source. Like, because if you got the human readable data, and it wasn't quite right, but you still validated that it didn't have any customer data in it, then that may be okay to be sent out. But I'm assuming open source would be preferred. I just don't know if it's mandatory or not. But
I mean, it has to be something that they could audit, right? Because they're going to want to audit the tool and see what it's doing under the covers, right?
Yeah, or if
That's usually what I've been told is if it's a tool, then they have to, I mean, they're going to have to, because they don't want you to kind of, in the tool magically disappear certain things.
Yeah, and I mean, maybe open source. I mean, I hear also open source might be the wrong word. Maybe put a quotation marks around it just in case. Because it could also be like maybe
And it could be. I mean, I was told it needed to be. The customer had to audit it. So I mean, it could be given as an NDA by some whatever, but it needs to be something that they can see the tool and audit the code, right? That was my that's what I've been told, at least with the customers I've dealt with.
The thing that I have in my head is that the format's well enough described that I could build my own tool if I wanted to. Right? If I don't trust your tool, I can build my own.
Yeah.
I don't know. Yeah.
If it's a known format and customer wanted to write their own tool that was closed source, they could do that too. Yeah, I agree.
Yeah.
So
Yeah.
yeah.
And that's why I asked the question, is that something we should think about? Is there, you know, is there acceptable formats that we want to recommend at a minimum and stuff?
Yeah, I mean, I think it definitely belongs on the potential to-do list, right?
Yeah.
Because I mean, when it comes to the like all these dumps, right? Keeping them, you know, they well, we can always inflate them to be gigabytes of data. That's for sure, right?
Well, yeah, and there's something to be said if
that's,
we're
that's
in
always,
agreement.
That's always perfectly possible. I mean, and gigabytes of data of raw information, right? And then if you further inflate that by having to be, you know, an actual like ASCII construct, um, that's um, that's a burden, right? For sure. So I think, yeah, let's put that on the potential, you know, list of things to do as we talk about transporting these dumps, right? Having a, you know, defining a compact dump format.
Well, and then I guess the other thing I struggle. I mean, like ASCII is one thing, right? I mean, it's just a bunch of letters or numbers. But don't you need something that translates that or breaks it down into what each one of those numbers means or each group of numbers means in order for it to be something that could be auditable
Yeah.
or
Yeah.
I think that's the key piece. At the end of the day, it whatever it is, it has to be readable to the
and
point
mappable
where because the ultimate thing is privacy, right? You want to make sure you're not giving away your tenant's private data, so that's what they have to audit. So it has to be readable to a point where they can determine if there's any of that type of data.
Maybe understandable, human understandable is maybe a better.
Yeah.
You got to read it, and understand it, right?
Yeah. Human understandable. Yeah. I mean, and I think Jason picked on it nicely, right? ASCII is probably a bad example, right? Just because it's a bunch of characters doesn't mean anything, right?
Yeah. But I've seen that. I mentioned the ASCII because I've seen that actually being required. I've seen that required to me on certain things. I'm like, okay. And the same thing, like you said, Jason, I can give you a whole bunch of letters, but if it's gobbledygook, you still need your decoder ring to figure out what XXX54 means.
Exactly. If I turn my 8 bits in a byte into 7 bits just to fit into a character, right? Then you've done nothing. Yeah.
Okay.
But I think that's going to be an interesting topic that we'll probably have to come back to and see, is there something we can do to make it easier for for those sysadmins.
I added a slide to my version of the deck that has things to standardize, and the compact dump format is the first thing I've at least mentioned there as an idea. I think it's definitely a valid idea.
Okay.
That we shouldn't easily discard. Yeah.
All right. Well, then moving on to the other one, I think a lot of other ones mentioned that you may have limited access. And again, I put in the data center because in pre-production you probably have full access, but in the data center you may be limited in what you can collect. For reproducibility, I put as I mentioned up here, we kind of prefer the self-heal, but that's really only super helpful if it's mostly transient errors. As I mentioned, if the frequency gets too high, that would be too disruptive. And even if you can self-heal, if you're having to self-heal every couple of seconds, that's probably too much disruption. And so for high reproducibility ones that, as I mentioned, you may have to do more. You may say, okay, well, I gotta go the host could go enable the more detailed debug reports, or you may say, I'm going to move this back into the data center quarantine state so that I can get more debug data or whatever, right?
Yeah, I think that there may also be some, some escalation around the self-healing that, along the lines of, let's say we have something that's, pretty quickly at self-healing, like, if your NVMe drive has resets, 10 times within a minute, you should probably just stop doing that.
Yeah.
We're
Yep.
broken.
Mhm.
Instead of, like, the node declaring itself healthy, almost receiving a workload and then crashing again, right?
Yeah. Okay, so then going down to the actions, we discussed this a little bit before, but yeah, generating a crash dump and then storing it persistently if possible. This because if the something happens that prevents you from getting it right away, if it's and by the way, that was kind of also I think they had this up in the CPU one as well. Yeah, save collected. So some way to get this in permanent storage is may be helpful. If the device can do it, that's great. Otherwise, if the host can collect it and store it in persistent memory or send it out over the network or whatever, that may be useful as well. In addition to generating a crash dump, you probably want to notify the host that this happened so that the host can decide what it wants to do. Maybe it does nothing if it was auto recovered, or maybe it says it wants to collect the crash dump or whatever the host does. It can choose to do based on that notification.
Mm-hmm.
So the host may choose to retrieve that. This is what I was talking about, and store it. If the device didn't store it persistently locally on device storage, if they don't have persistent storage, for example, then the host may read it and store it locally or transmit it to an external server for storage. Yes.
I mean, probably also even if the device does, right? Like,
Yeah.
unless the device, is an NVMe drive or has access to a sizable NVMe drive, it can probably hold like one, like, single digit number of old crash dumps, right?
Yeah. Yep.
And I mean, in the single digit, like might be one. The number might be one in many cases, right? If you have a device like a like a GPU that doesn't naturally have sizable storage attached to it, right?
Yeah, it depends. I have seen, designs where there's special for persistent storage, specifically to store GPU data as well. So it depends on the design, and if you want to incur the extra cost of putting some kind of persistent memory storage down. But yeah. Okay. Once this data is retrieved and available, then you may want the customer may want to analyze that data. They may analyze the data themselves, or they may say, you know what, I want to send this back to the system makers, to the OEM, or to the component vendor if necessary, if they want assistance in troubleshooting. Oh, and I mentioned this again, just we talked about this one before, but yeah, if you crash, you generate a crash dump, the host can retrieve it, but if possible, still would want you to self heal if that's possible. I'll put a few examples. We discussed some of these earlier. If self healing doesn't work, then the user may opt for manual intervention. They may say, well, let me just, if this is a once in a blue moon thing, I'm just going to, power cycle the server and see if that fixes it. If not, then maybe more drastic manual intervention is required, like taking it into the data center quarantine state or what have you. Like all of these, it's just a good, if a good action to take is if something goes wrong, you want to check your firmware and software configuration, make sure everything is up to date and all that kind of good hygiene stuff. If you're in the deployed state, again, I mentioned this one earlier, and it was in the flow chart, right? Where if the devices or whoever's only collecting a little bit of debug data, but you keep seeing something, you need more information, you could go enable the devices or the system to collect those extra logs or traces or whatever, so that the next time it happens, you can get that extra debug data. And then finally, I put here, if you do decide to go into the quarantine state, then one of the actions, first actions you might want to do is kind of do the general hardware inspection and make sure it's not something obvious like misseated component or cable or these sort of things before digging into all the rest of the diagnostic and debug data.
Yeah, and I think the part of that is that ideally, especially the human understandable part of the data should really give you hints like that, right? If you have a, if you have a, I don't know, network cards or a card with a network connection crashed because the network cable disappeared, right? You kind of want to know about it, right?
Yeah, another one we see.
You want to get to the you want that hint quickly, right? Like,
yeah, another one they would see a lot actually. In AI servers in particular is if you have a PCIe link go down, well, it could be the component on the upstream side of the link went bad. It could be the component on the downstream side went bad, but most often what's probably is there's a connection issue, especially if you're using cables to route your PCIe lanes, right? So that would be one where if I saw a PCIe link go down, checking the cabling is probably the first thing to go look at, right? So yes, if you had that debug data that says link went down, that would drive you to go do that. Yeah.
Yeah, or maybe link went down, and by the way, error rate was the correctable error rates have been pretty high all along, right?
Right. Yeah. Yep. Yep. Exactly. Yeah. So if it was kind of flaky and then died, yeah, you'd probably see a whole slew of errors before it went down. Exactly. Yeah. Yep. Okay. That's
Sorry, one other, I guess, question here. Maybe I missed it. The enabling extra debug info. I'm thinking back to that flowchart thing. It also talked about debug dumps. Is that sort of the idea there, or were you thinking something else with the extra debug info?
Yeah, that's what I was thinking. Is like maybe the device collects a certain amount of data because it would be too invasive to always collect all the data. But if the host kept seeing some issue and it wanted more debug information, it could go in and say, hey, I'd like to enable you to capture extended register dumps or trace dumps or the extra control plane state dumps or whatever other kind of extended debug data may be necessary.
Yeah, and then when we're talking about not crash dump, sorry, I think you used the term crash data. When you use crash data, you're talking about each one of those circled items, and it will actually collect SOC control plane state dumps is not circled. I forget if that was intentional or not. But I guess going back to the human readable form, if I'm doing something like a trace log, I guess depending on what that really means, right? If that's something that's not encoded or that maybe that does require a special decoder ring, like what Enrico was talking about. Something like an SOC control plane state dump sounds like more of like a micro arc thing. I'm just wondering, how do we give people confidence that something like that doesn't include the user data, which I guess per the parenthetical, it doesn't.
I'll give you a real world example, and again, I'm going to go back to NVMe since that's what I'm familiar with. So as I mentioned, there's like the 3 different data areas: the data area 1, 2, 3, 4. And so the data areas 1 and 2 have well-defined format. They're in a binary format, but there's an open source tool that can parse that. And but it doesn't include trace logs. So they haven't defined. It's got a bunch of error counters and stuff like that, but it doesn't have like firmware trace logs. Most NVMe device vendors put their firmware trace logs in the encrypted data area 3 or 4. And so if you're in a data center that allows encrypted logs to go out, then you may say, yeah, I want to collect that encrypted trace log and send it back to the vendor for analysis. If you're in a data center that doesn't allow the encrypted data to go out and the trace logs are always encrypted, then you wouldn't be able to do that. Is there an appetite to define a standard trace log? There may be. That may be a valid thing to go explore, but at least in some devices that doesn't exist today. And what they do is they it's actually a little bit funny, but it says in the spec, it says, hey, every bit of data that you need to root cause the issue needs to go in the human readable form, right? But all the of course that's I think practically impossible, right? So there's but I think the gist of it though is they try to get as much human readable stuff to figure out what's going on, and you'd really only try to use the encrypted stuff or lower level stuff for extreme cases, right? And if you did hit one of those, right, then you'd have to look at trying to reproduce that in a the OEM lab environment or the device vendor lab environment and try to collect those encrypted logs that way instead of relying on the customer to send them.
Yeah, that makes a lot of sense. Do you mind like sending a pointer to this the NVMe specification? There may be a few of them.
I think I put them in the minutes from last week, but we can.
Okay. I'll pull them from that then.
Yeah.
Thank you.
Yeah, and I mean the thought I had on especially on the log side, since Jason was picking on them, right? Like, and maybe it's again it might be subject to discussion, but like even if they're human readable, right? Does not necessarily. I mean, even if they're like plain English ASCII text, right? There might still be, especially when they become like micro-architectural firmware traces, it might still make no sense to anybody but the person that wrote that piece of code, right? I think that's again kind of to the maybe difference between human understandable and ASCII.
Yeah.
Jason, does that make sense what I'm saying?
Yeah. Yes, it makes sense to me. Yeah.
Yep.
All right. Okay, I got some time to look at. All right, go take the share back and let's see if you have some. Okay. You should be able to see my screen now. And I want this to be definitely interactive. So me and Enrico we've done this probably a couple of weeks ago, and basically primarily looked at this flow at the times and the other ones that we had well walked through it to then, and I said like, okay, what are actually the debug activities that that are part of those flows that we may want to then in this work group define on how to do it, right? How to extract them. And here's kind of again the first list, and I insist that it's incomplete. So if you let's jointly add to it. So okay, so the first one we're gonna have here is really dump extraction. And I've kind of looked at this a little bit broad, right? As there is you know the crash dump, especially since we just talked about it, right? Is essentially a time dump, right? That is triggered on a device event, right? As in crash. So and that's kind of one of the timing constraints. The other one, it could be something that is the user triggered, like especially like in the performance example, right? There's stuff still runs, but I may still want the entire information dump, and then I think especially with the AI systems where we have potentially thousands of GPUs working on one training job, right? I think the idea of cross triggering these dumps is going to be more and more important, right? Because it could be, while GPU number 5 crashed, the hint on why GPU number 5 crashed might be on GPU 2024. So I think this cross triggering is going to be more and more become more
yeah.
important here.
So okay, so cross triggering, I guess it's okay. I think of cross triggering. I think of maybe something else. But this is really externally triggered or something within the larger system triggered.
Yeah, I mean, if you have a better word, I love it. Yeah,
I don't, but I guess maybe your explanation of what it is probably what we need afterwards after it, so to help,
yeah,
I guess, clarify what it is. That
Yeah,
makes
it's
sense.
another component
I
sending a trigger to you to do something, right?
yeah. Other
Yeah.
So there's user triggered, that makes sense. Cross triggered is really
It's really
a
externally triggered.
externally, or I was thinking even like system triggered. There may be a system
Mhm.
event that may be a system level exception or something that happens.
it could be
And I
even
don't know,
an
system is ambiguous because I don't know if that's
yeah, I
what
mean,
that means. But then crash is what I want to get back to. Is that really OS triggered, or what is crash? Because that's we haven't really defined what crash is, right? And maybe we just leave it as open and just say it's system dependent. But
yeah, I mean, yeah, we should probably define it as what crash
but
is.
I think,
Maybe we'll get to it. Not sure I want to do it today,
Marco,
but
yeah, but Marco, when you and I were talking about it, I mean, it came down to, I think what we wanted to differentiate is, a crash is like a bad situation, right? Versus, just something interesting is happening. And when something interesting is happening, that could be the debugger, the person, the user triggering it, or something else is triggering it, right? Instead of a terminal state, right? I think that's what we're trying to to differentiate here.
So maybe crash is really this, I guess the scope of whatever this has crashed, and then cross triggered is something else has crashed.
Right? Outside of that scope.
Okay. Outside of the local scope. Yeah.
It may not even be a crash event, right? Because I kind of my
it's a terminal event. Something you can't proceed.
Yeah, well, maybe not, right? Like I could completely, let me make my performance.
But Marco, that's the point. The point is it doesn't have to be a terminal.
Exactly.
It should be a terminal.
I mean, Austin presented something already, right? He talked about the self-healing and the fact that there may be fatal errors, which aren't, I guess, maybe system fatal, but and all of those sorts of things would be, I think, maybe the first bullet. Well, I don't know. So if I'm self-healing, I would think it's the first bullet.
Maybe it's something like, again, from the perspective of the debug scope, right? The thing that's being debugged. Again, it just depends on, is it, a device, a block, whatever. There's
How about
I
this one?
guess I guess there's three things. There's auto triggering, right? A crash or something like that the hardware automatically triggers it. There's the explicit user trigger, and then there's a external trigger from outside of the scope of what is being debugged. Right?
Yeah, so,
I mean, that's really what it comes down to, right?
Yeah, so maybe if you look at this, so here's what went through my head, right? And I typed it in here, right? The crash is really, if I look at this from a device perspective, right? And it's maybe I'll put this right. So from a device perspective, let's say it's a GPU for sake of argument, right? The crash is really a self-triggered thing, right? The GPU
Right.
knows something went bad, something happened that warrants a crash, right? It knows it in of itself, or warrants a dump, right? And the I have completely fatally crashed is the the poster child of the self-triggered thing, but there could be something else, right? Maybe we'll have other events that my example, my device, my GPU can detect it by itself and generate these logs. This is the dumps, but even if they're not crashed. But that's a self-triggered idea, right? Then there is the user-triggered idea of I go in there and say, give me a dump now. And then this one is the trying to I don't I please give me the right give me suggestions for the right word here. But really the idea is in the something in the larger system sets off the trigger, right, to get the data. For the extreme example, let's say we have a performance issue, we have application code, a trap that detects that the average compute throughput is dropping, and every time that happens, we want everybody to dump, right? External internal system. I don't know. Somebody has a good name for.
Yeah, we can wordsmith it, but I mean, I think you got it, right? Self, user, external. I mean, those are the three different.
External. Yeah, and it's external component, but maybe inside the system, right? Some event makes this
yeah, it's not self-triggered.
Not self, yeah.
Well, I don't know what the antonym of self is.
Maybe it's API triggered. Oh, no, I will not succeed at this today.
Yeah,
for sure. Let's move on. So then the next thought we had was like, okay, if there could be a separation between when do I collect and when do I extract. And it could be in the go back to the crash example as a poster child, right? I might collect this on every crash, but as Austin was outlining today, right? Maybe on the first crash we collect it, we self heal, and then if this is the only the first crash and we don't see another one for a year and a half, nobody ever goes and collects that, right? It could also be a thing that as part of the self healing, and that's something we've been internally having fun with, right? Is like, you know, if my response to if my self heal action is a reset, right? Um, do I have to wait for extraction before I can complete the cycle? Kind of problem statement. Or is it something that it's quickly collected, put into some memory, and can be extracted a week later for sake of saying something. And then we got kind of
So Marco, I'm just going to give you using the amazing AI. I got three different. I got the three names. I think they're pretty good. Self, user, and external stimulus.
external stimulus. I love it.
There you go. I'm horrible with names, so I had to ask a better expert.
And that better expert actually only just randomly complete sentences, right? Because that's how I model actually works.
Yeah. I have it in the chat if you want to just cut and paste and move on.
Okay.
Sorry,
External
I just
stimulus.
it was bugging me. External could mean the user, and I was like, what is the other word? And yeah.
External stimulus. Very cool. I put that on a flashcard for next time I interview somebody. All right. What do we got? We get some ideas of what the content might be. Okay, I don't have to read the slide. So, okay, so that's kind of the thinking about dump. And the next kind of type of debug activity we kind of see is really getting logs or traces, which could be a streaming activity, could be a um, um, every time it could be a streaming activity. It could also be, what do I call it? Basically a pull a file kind of activity, right? I'm gonna at any point in time go pull my log, however long that log have to be maintained. I pull that out. I put it, in my text editor and try to figure out where and why things went wrong. Then there's various aspects of performance monitoring, which is probably really telemetry and streaming telemetry. And whether they clearly contribute to debug is probably something I'm gonna go advocate, claiming that that's some other work group that deals with that. And then the one that's interesting, and seeing that we have only two minutes left, maybe I leave this for more discussion next week, right? Is really the notion of kind of interactive debug. I have a couple of examples here, and maybe my personal bias against runtime run control in real use cases. So I got that as an activity, and I suggest we dig into that a little bit next week. And then what I captured today from Austin was kind of the importance of setting verbosity. Right? I think that's all this you know enable more richer crash dumps, yada yada yada.
And there's verbosity, filtering, and all the other fun stuff.
Yeah. I just call this a setting verbosity.
Yeah.
We're happily out of time, so I think we just continue here next week. What I would request, if you have any of you can think of debug activities that I'm missing here, and I insist that I'm missing some, just send them to me or add them to the slide for next week's discussion.
Sounds good.
Sounds good. Awesomeness. Thank you.
Bye.
All righty. Take care. Thanks.
Take care.